Greetings to all of my fellow learners. I would like to give you all some information about Avogadro's law. But before that, for you to understand Avogadro's law, in 1811, a mathematician physicist named Amadeo Avogadro stated that an equal volume of different gases contain an equal number of molecules. If we observe our surroundings, there are many representations of Avogadro's law in our everyday life, but we overlook it. There are also problems that Avogadro's law is applied for us to solve it. So in this video, we will show you further information about Avogadro's law. This video will contain definition, mathematical representation, experiment, and real-life representation of Avogadro's law. So stay tuned, and I'm hoping that you will gain knowledge in this video.
Avogadro's law. In Avogadro's law, where a gas has physical behavior and it's described by four basic properties of gases: the pressure, the temperature, the volume, and the number of moles. Avogadro's law is the relation which states that at the same temperature and pressure, equal to volumes of all gases contain the same number of molecules. The volume of a gas is directly proportional to the number of moles of a gas present. This can also be expressed as V over N is equal to K, where V is the volume of the gas, N is the number of moles of the gas, and K is a constant for a given pressure and temperature. This law was described by the Italian scientist Amadeo Avogadro in the 1812. In Avogadro's law's formula, we can write the formula as V1 over N1 equals V2 over N2, whereas V1 is the initial volume, N1 is the initial number of moles, V2 is the final volume, N2 is the final number of moles. In this formula, we can say that under a certain condition of the gas, increasing the volume would result to increasing the number of moles, or decreasing the volume would result to decreasing the number of moles. For example, the initial amount of dry ice is 1 mole and occupies a volume of 2 liters. What is the volume if we increase the amount of dry ice into 2 moles? First, identify the given. So we have the initial volume, 2 liters, we have the initial number of moles, 1 mole, we have the final number of moles, 2 moles. So in this problem, we are going to find the final volume. Second, substitute the value to the formula. Then third, solve for the final volume. Then the result would be 4 liters. So our final volume is 4 liters.
Now that you know the meaning of Avogadro's law, let's have an experiment. You need 3 bottles of Coke, 6 Mentos, 3 balloons, and a marker. Now Ms. Dohio will show you the procedure of this experiment. Now this reaction is mostly due to the process of nucleation. Because of this process, carbon dioxide in the soda is attracted to the metals. That creates so much pressure that the bottle soda may or may not explode, meaning all the carbon dioxide is squeezed into the liquid, finding its way to escape. So in the case of our experiment, the carbon dioxide escapes from the bottle into the balloon. So the more Mentos added to the soda, the fizz or the moles will increase. Hence the balloon will increase more and more likely expand, and also vice versa. As you saw from the experiment shown, the reaction of Mentos and Coke created gas or the fizz that inflates the balloon. Now we usually see Coke and Mentos in making mini geysers or mini experiments back dating at least 2005. But this time, we used it for an example of Avogadro's law.
The most common example of Avogadro's law in real life is simply breathing. When you breathe in or inhale, the air molecules you intake causes your lungs to increase in volume and expand. On the other hand, when you exhale, the air in your lungs begins to leave the area, causing your lungs to reduce its volume. Another example is when you blow up a balloon. If you increase the moles of gas by blowing inside the balloon, its volume increases because the amounts of gas being transferred rises. When you let the gas out, the balloon loses its volume and becomes smaller by size compared to the balloon filled with gas. And lastly, a tire. A tire can also be an example of this. When you puncture a tire by using a sharp object, the air molecules escape through the hole and the tire starts to deflate.